18.3, the last section in chapter 18, we're going to finish talking about sound. And when we talk about sound, we have to talk about a cool effect that sound can have, and it's called Doppler effect. Now, what is Doppler effect? It's defined as the change in sound frequency caused by the motion of the source. So essentially what happens is when sound approaches you, so when a moving object is making sound, when a moving object makes sound and it's coming towards you, you hear it at a higher frequency because the waves are bunched together. And when it's moving away from you, you're going to hear that same object at a lower frequency because the waves are moving away from you. Now, if that object was stationary, like a car horn, it would make the same sound. But since it's moving, when it's moving towards you, the waves bunch together, and then you get a higher frequency, and when it moves away from you, you get a lower frequency. What are some examples of Doppler effect? So you can kind of see here a police car or an ambulance car. As it's moving towards the person carrying the box here, the waves get bunched together, so it's a higher frequency. But as they move away from the lady, they get a lower frequency. Do we have anybody who watches NASCAR? All right, a lot of times they'll have the camera on NASCAR right next to the racetrack when they're coming down, and it sounds something almost like this when all the cars are going by. Right? What happens? That initial is really high, and then what happens once the car passes? It's zoom, 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 zoom. Right? That zoom is much lower frequency than the zzz up top. So when sound is approaching you, it's going to make a high-pitched sound. When it's moving away from you, it's going to make a low-pitched sound. Now, to kind of give you an idea of what that sounds like, all right, here's an example of a train. All right, a train. I'm going to let you watch this video here, and I'm going to hold my microphone up to the volume just so you get an idea of what it sounds like. A train's moving by. When the train's coming towards you, the horn is going to have a higher pitch, and when the train is moving away from the camera, it's going to have a lower pitch. I hope you were able to hear that. If not, I'll give it one more shot here. And you can hear that, right? You can hear that also with the cars. You can hear that with the cars as well. So just a little additional thing with the Doppler effect there is you can hear that with cars. Lastly, let's talk about the ear a little quick. How does your ear hear? The ear is actually a very complex system. And we've talked about before, you can lose sound, or you can lose your ability to hear quite easily. So the ear is a complex system. You have three parts of your ear: the outer ear, the middle ear, and the inner ear. The outer ear is just focusing on gathering and focusing sound. The middle ear receives and amplifies sound, and the inner ear uses nerve endings. You have little hairs inside your ear that sense vibrations and send signals to the brain. What happens is you can dumb those hairs or dumb the nerve endings when you listen to sound too loud, and once those nerve endings are damaged, they will never grow back. So that's how people lose their hearing over time. And hence why you would need a hearing aid to help amplify the sound in the middle ear to make it louder, so you're more sensitive to those vibrations. We are going to talk about this in the class a little bit rather than trying to dive into the diagram online. But essentially, you can see here, here's the inner ear. It travels through your ear canal. All right, when you pick your ear, you get earwax developing. I know, ew, gross, but it develops in the ear canal here. That's just a way to clean this out. That's why you have earwax, a way to clean it out. Eardrum here, it starts the middle ear. This is essentially what amplifies the sound. If you have sound too loud, this is just a really small sheath of skin stretched over the ear, like a drum. And anytime you hear a sound, the drum's going to vibrate back and forth, which causes the three bones in the middle ear to vibrate, which sends signals to your inner ear in your cochlea. And we'll talk about kind of how this works in class a little bit more. But the big thing is you have three parts to your outer ear, middle ear, inner ear. You have in your middle ear, you have your eardrum, your three auditory bones, the hammer, the stirrup, and the anvil, which are the three smallest bones in the human body, by the way. And then you get to your inner ear, and your cochlea is really responsible for your ability to learn, or not learn, hear. Sorry. So there we go. So how is sound produced? Sound waves can be converted into electronic signals that can be processed and stored. That's kind of how your brain works. It sends nerve signals with an electronic signal to perceive sound. Uh, that's how microphones work. That's how iPods, boom boxes, CD players, like you guys know what a CD player is practically. All right, but sound is, you can use it and you can convert electrical signals back into sound waves, and that's how radio works as well. So just a cool little thing about on sound there. So 18.3, we have Doppler effect. Doppler effect's a big thing. When sound is moving towards you, it's going to be a higher frequency. When it's moving away from you, it's going to be a lower frequency. The ear consists of three components: outer ear, middle ear, inner ear. Your outer ear is the part you can see. The middle ear is your eardrum and the three bones, and your inner ear is your cochlea. And again, we're going to talk about those in class. But this is the end of section 18.3. This is Mr. Klenner, and I am signing off.